Hello everybody, welcome back. Today we're continuing with 3.3. We're looking at example 4. This is the diagram at the right. Shows the plan for a roof with support beam DE. There's your roof. This is the support beam ED and it's parallel to AB. The local code requires to be between 70 and 80 degrees so that snow and ice will not build up and it'll slide off. Will this plan pass the local building code? So we have the dimensions here. We have 10 feet. This little line indicates feet. We have 20 feet, and this is 19 feet 6 inches. Okay, so we have the side lengths. So we have side, side, side. So we know that we're going to use the law of cosines, finding the angle. So the interesting part is, since these are parallel, that means that angle B and angle E are corresponding angles. So we're going to find angle B first, and once we find angle B, that's equal to angle E. So we're allowed to do that. All right? So that is the important point there. So I'm going to take a smaller triangle out just so you can see it. So this is the triangle simplified. I use the larger triangle here. Notice that it says 19 feet 6 inches. So here I put it in terms of just feet, so it's 19.5, right? Because there's 12 inches in a foot, so 6 inches would be half a foot, so it's 19.5 feet. That's important. All right. So I have my law of cosines here. I've rearranged for cos B. Okay. We'll plug everything in that we know. We know the side B is 20 feet. We know the side A is 19.5 feet, and we know that side C is 10 feet. We said A was 19.5 and C was 10. So we fill everything in. 20 squared is 400. 19.5 squared, 380.25. 10 squared, 100. Now the denominator, negative 2 times 19.5 times 10 gives us negative 390. Subtract the numerators. So when we subtract the numerator, we get 400. Subtract 380.25. Subtract 100. We get negative 80.25. And you can leave it like that if you want, or you can divide. It's up to you. Divide by negative 390. Gives you a decimal. So what I do is I'm just going to leave it like that. And again, the negative divided by negative is a positive. I'm just going to leave it like that. And now I'm going to take B. Then I'll take the inverse cos of that. Like I said, the reason I'm just leaving it as 80.25 over 390 is, alternatively, it's just a big decimal. So I don't see the point in taking that. But again, it's up to you if you want to take the decimal. It'd be 80.25 divided by 390 and take the inverse cos of that. So I'll do that on the calculator. So second function cos, and we got at 80.25 divided by 390. They're both negative, so I just made it all positive. And make sure your calculator is in degree, as you see here, it's in degree mode. And you get 78.125 and so on. So you get angle B is equal to 78.125 and so on. So we can just round it to the nearest, and we get 78 degrees. Okay? There we go. So since 78 degrees is between, and we look up here, it needs to be between 70 and 80 degrees. That was cos. The angle formed by the formed at the peak, I guess I should say, at the peak will pass the local code. And that's it, right? Remember, angle B and E, they would be equal. They'd be the corresponding angles. And there's your answer. All right, next we're going to finish out the chapter. We're going to do the final example, example number 5. Example number 5 says a 3-point star is made up of an equilateral triangle. So there's an equilateral triangle means all the sides are equal and all the angles are equal. All right. Determine the length of each side of the equilateral triangle. Length of each side in a 3-pointed star. So we're looking for the both side length there, and obviously they're the same. Okay. So let's work this one out. So since we have side angle side, we can find a side here directly. It's going to be the side opposite of 20. We're done. So we take our... So you can take this out and label it if you want. It's not a bad idea, so that's what I'm going to do. So we've labeled it X, Y, Z. Well, the book did. You can call it A, B, C. It doesn't make a difference. But we're looking for the side opposite of X. So this would be lower X. B and C don't matter, so we'll just call them Y and Z. All right. So this is Y, Z, and we know angle X. Right? So here we are. So that's our formula. So what we'll do now is we'll fill in what we know. Okay? So we know the side Y is 60. We know Z is also 60. X and Y are 60. And the angle is 20 degrees. Alright, so let's work this out. 60 squared, 3600. 60 squared again, 3600. 60 times 60 is 3600 times 2 would be 7200. Cos 20. So we get 7200 minus 7200. Cos 20. Remember, this has to be done first before you subtract. If you subtract it, you'll get 0 times cos, and you get nothing, and it doesn't make any sense. So I take the 7200 cos 20, I get 6765 decimal 78687. Subtract the 2, I get 434 decimal 2131303, and so on. All right. Alright, and now I just have to take the square root of both sides. So x equals square root of, square root of this number. Again, I'm going to show you how to leave that in your calculator when you're using the calculator that we have in the class here. So remember, if you're using this calculator, here's how it looks. So we got 7200 cos 20, and then we had 7200 minus that. We have 434, so we go second function square root, second function answer, then we get 20 decimal 8377. We get x equals 20 decimal 8377, and so on. And it said to the nearest centimeter. So that means that x is equal to, the 8 rounds to 0 up to 1, so it's 21 centimeters. All right, so that means that each side of the equilateral triangle is three-pointed. Star is 21 centimeters. And that's it. So we're going to work on these questions here, page 137, number 2, 3, 4, 5, 9, and 13 for applying the cosine law. In the next video, we'll finish off the chapter. In the next videos, when we look at solving problems using acute triangles, 3 decimal form. So thanks everybody for watching, and we'll talk again soon.